like an intern position. And I literally got the invite like 2 days back. So
No
I've just
way.
been doing a bunch of tags questions. So
All right, so like TLDR is you have a Airbnb internship position or internship interview,
yeah, yeah.
and you've only been preparing for 2 days?
Well, like I've been preparing for like the past like week. I didn't know like when it would be scheduled,
Oh,
but
okay.
then it just got scheduled. So
All right, so like how do you feel with leak code in general? How many questions have you done?
I've done like a fair few. I'd say like think like 100 to 200, but
100,
a
200?
lot of the a lot of the like harder leak codes that I've seen like for the tag questions are like very like tricky,
Yeah.
and I've just been like I don't know, would you say like a lot of interns get asked like harder or like medium level questions?
It really depends. I don't think they'll ask the hardest questions, but they'll definitely ask mediums and maybe easier or harder easies and mediums, and maybe
Okay.
it depends on the company, but let's test your skills. What kind of questions do they ask? I've never interviewed at Airbnb or looked at any of their questions before, so I'm not sure what they ask. What are they? Is it usually arrays? Is it usually graphs?
From like what I've seen on the tagged, it's like a mix. And I I like looked at like they sent me some like practice material on HackerRank. So it's going to be conducted over HackerRank. And from what I saw, I think it's like around like medium to hards. I think there's some graph and some like DP questions. Um,
Okay.
but it really depends.
All right. Okay. The way I'm gonna run this interview is probably gonna last about 45 minutes. We're gonna do
Okay.
try to do two questions because I just want to see where you're at with different concepts. So by the time 20 to 25 minutes hits, if you haven't solved the question, we're going to move on to the next one because we're just here for prep. So I just want to
Okay.
see how
Okay.
you do in maybe in a couple of the topics. So the first question I'm going to give you is, let me think. Hold up. Let me grab a question. Let me grab the question. All right. So pretty much this is what's going to happen. We're going to be given a array, right? And the array is gonna have some starting values. 1, 3, 5, 6, right? Make sense so far?
Okay.
We're gonna be
Yeah.
given an
Yeah.
array with some values, and then we're gonna be given a max, which is equal. It could be a random max. So let's say the max is 10, and then we're gonna be given a list of operations where each operation is gonna have the index and how much and the delta. It's gonna be index. So the index say 0 and we say delta 5. That means or we'll say increment is how much we're going to increment the 0th index. If at any point any of the indexes go over the max, we want to reset the array back down to the original. So 1, 3, 5, and 6. So for example, we have 0, 5. Say we have 0, 5 like this, right? And the max is 10. Say for the first index, we have 3. So after this first operation, the array, we're going to increment index 0 by 5. So this equals to 6,
Okay.
right? The second operation, index 1 is going to go up by 3. So this is going to go to 6. On the third operation, we're going to go increment 5 or the zeroth element by 5. That goes to 11. That's over the max. It has to be strictly over the max. And then we have to reset everything back to the original.
Okay.
So
At
essentially,
what point
or go ahead.
would we like at what point would we terminate? So after we hit this and reset it, like would we terminate or we just terminate as soon as operations end?
By the end of the operations, I want you to tell me what is the final state of the array.
Oh, okay. I see. I see.
Yeah.
Okay. 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 I think I understand it. Um, so another question I wanted to ask. So at any point we hit our max, right? We have to reset it to only this original value.
Yeah, so you want to reset the array to its original state.
Okay.
Yeah,
Okay. And that's the very first state that the array was at, one, three,
exactly.
five,
Yeah,
six.
the
No
beginning
other state.
state.
Okay.
Yeah.
Okay. And any value can change to the max, and we want to return this. Okay.
Like if any value goes over the max value, if any index, we want to reset
Hmm.
back to the original.
Okay. Okay. I understand. Okay. Um,
What are your thoughts?
Yeah, so I'd say then I would want to like depending on the operations, right? The operation, the first element of the operation lists like which element we're choosing, and then like we only have increment, right? So there's no decrement. So if this
Yep.
value is let's say instead of 5, this value is -2, would we still add or
Let's just assume all of it is positive. Well, I don't
positive?
know
Okay,
if it would
okay.
really matter here, but yeah, let's assume that it's all positive.
Okay, so assuming that it's all positive, then we increment to the ith element this value, and as soon as we check that, we are looping through operations, and we're doing the operation. If our operation results in uh, an element being greater than the max value, then we have to reset. So I'm thinking first off, we do need a temp array to store where our original array is.
Sure.
And then as we're going through operations, we're going to continue to modify our array. Or I guess actually we can modify like so we can take a copy of the array and then modify that copy, and then depending on any time we hit this max, we can reset the entire array to this original value. And we're just going to iterate through all of operations while
Okay.
checking for this if condition is what like my logic would be and like my approach would be.
Okay. So what would be sort of the runtime complexity of that solution?
So we have, depending on how many operations we have, let's say we have like n operations, then it would be I think an O of n solution. And since we already have like a stored previous array, every time we reset, all we have to do is just change the values of like our copied array to like those new values. So I guess that operation um would like add to, depending on how many times we are like resetting, I think that would also add some complexity. So but I'm
Yeah.
just assuming that I'm just like setting it to that value.
Yeah. So what would be the final runtime complexity there?
So I would say I think it's linear, because I think since we can just set the array directly, that would be O of n or O of 1, and then linear for the number of operations. So if number of operations is n, O of n.
But then you said at some point when you reset, it's gonna cost you another O of n.
Yes. So since I'm just like changing, like let's say like our array to, I'm just directly setting it to like our copy, right? So array or a copy is equal to our original array.
Okay.
I think this would be O of 1, I want to say, because we're just directly copying over that reference.
Uh.
Um, and like we're just setting all of the values. So but I think actually does the I think the dot copy, if we're doing this, this would, yeah, I think this would cost um another, like depending on the length of our array, yeah, it would cost like that and add that to our complexity. So I want to say I think then my final time complexity would be depending on the a number of times we hit our max. Worst case, it could be O of n times if there's m elements in the array, m. So O of n times m. If we're like
O of n
repeatedly
times
hitting the
m.
max
What if we just kept hitting the
and like we have to
max?
reset.
Yeah, that
Yeah, yeah.
that makes more sense,
So we're
right?
saying,
That time analysis. But
yeah, yeah.
if we are hitting the max on every single operation, pretend it was 0, 11, that would degrade to O of n squared. No.
Um, so you're saying every operation is hitting the max and we have to reset every single time?
Yeah.
Yeah, yeah, I think so.
So if I was the constraint, that would be a slow algorithm based on like we're gonna have a lot of operations. Let's say 10 over
Okay,
10 to the 8.
okay.
That just would never finish running. Is there any way that we could speed it up?
Okay. So then in that case, maybe we could look at how many possible like values we're previously changing. So like the difference between like the current existing array and the original array, and maybe try and like only alter the values that we have like previously changed from operations. So when we're resetting, we only reset those specific values. So for that, we would maybe need we would still have to loop through, but we would maybe need, I think, a hash map to look for those specific values that was changed from operations.
Okay. So what would that look like?
Right. So uh I think it would be like a hash map, obviously storing all of the changed values. So let's say for example in this operation we have 6 is a changed value. So you're storing the 0th index, and that's changed by X amount. So 6 is changed by 5. So we just store the 0, and then we store the original value that we want to set it to 6. And then again, we would have to just loop through this hash map and set the values based off of that.
Okay, so how do we know something went over?
Right. So we are still like this is based off of our copy. So if our copy of uh I is greater than our max, then based off of that, like if this is true, then we're going to still loop through like the values in our hash map and set them equal to this. So whatever is in our hash map, like we're going to say like for like key and value in hash map
Sure.
in like m dot items.
Yeah.
And then we're going to set in like for the copy, we're going to set in copy of m of I think it's so our key is k, so k, and we're going to set that equal to value v.
Are you talking about like
But
the deletion now or the reset?
the reset, yeah, this is the reset for the max. And I'm just storing every single time an operation happens, I'm storing the original value and the index.
Okay. All right. I think let's just start implementing. Let's see where it gets. I think you're on the
Okay,
right track. I think we can start implementing.
okay. Okay, so then let's define a helper with we're given an array and we're passed in operations. And let me just this is our conditional, and we're going to loop through um, O in for op in, let's call this OPS for operations, and we're just going to increment that certain index. So let's say first and val is equal to this. and this is our index. And so we do if copy plus value is greater than max, then we go into this. Else,
What
we're
is this
just going to
doing? For
do,
items, you're setting k equals to v.
yeah, yeah. So
Okay.
this is my hash map, sorry. Um, I'm setting it equal to the value in the hash map.
Okay.
And so else, we're just going to take copy of index and plus equal to value. Um, and yeah, and then we also need to make sure that um, if we do this, right, we need to update our hash map. So our hash map has to equal to the original value. So if um, index is not in M, our hash map is going to update with the index and the original value. So I guess I'll do this statement after, if that makes sense.
Mm-hmm. Keep going. Makes sense.
And then in the end, we're just going to return this copy that we had.
All right, wait. Walk me through line by line after line 20 for ops and ops.
Okay, so this is like iterating through all the operations. We from some operation we get our index and then we
Yeah.
get our value, and then we take at that index and we check is this going to be greater than this max value that we have.
Sure.
Let's define it as max. And if this is true, then that means that we're going to go through our hash map and we're going to, this is the reset. So we're going to
Yep.
reset the array through this, right? Else, this means that we're still in range, right? And if our index is not in our hash map, this means that we're altering a new value, right? We're altering a new index, sorry. So we're at a new index and we're adding to it. So we want to store what the original value is. So I'm taking m of index and setting it equal to copies index. And then after this, I'm just going to increment um, the original copy by our value. So this is just like adding the value at the end. And then in the end, just return the copy array, which is like the final result.
So does Airbnb let you run your code or no? Do they make you
I
run your code?
I, I do think so. I it looked like it was a hacker rank, so
Yeah.
I do think
I think they might.
they
So
let you run.
run it on a few test cases. Like run it, and I want to see it passing.
Okay,
Max
sure.
equals. So we're gonna put max as a
Let's
global
define,
variable.
yeah, and then I'm going to say helper. Let me say operations is equal to like this test case. Um, ops is equal to say this, and then let's say that uh, array is equal to 1, 3, 5, 6, and then let's just call our helper print helper array ops just to see if it's running. Oh, okay. Um, I think we can. Should I make this a 2D array or
Was this tuple is not callable.
yeah? So I think this I just need to make into a 2D array like this. I think that should be okay. 1, 3, 5, 6 is what is returned. So it hits. Let me just print out our copy and in each line just to confirm that. So it goes 6, 3, 5, 6, 6, 6, 5, 6. Then it hits 11, 5, 6, 5, 6. So resets it, and then
Answer this.
3356. Yeah. Okay.
Zero, one, two. Just run this. Okay. Wait, let me just verify. This part is interesting where the else statement right here,
Mhm.
if if it's not in here, that makes sense. We create it. But then we take the copy and we increment the value. Okay. Okay.
Right. Yeah. So
Okay, I
because
see.
we
I
know that
see.
it's not greater
Okay,
than
I
the
see. I
maxes.
see.
Yeah.
And it works.
Yeah.
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 That makes sense. All right. Okay. Let's move on to the next question.
Okay.
That was Q1. I'll put you on to the next question. And they're gonna ask you leak code. That's what they said. Straight up leak code.
I do think so. It did say it's conducted on HackerRank via Zoom, so I think it is like mostly leak code. And like a lot of the like the interview prep material they sent also said it would be like leak code style.
I
So,
see. All right. I mean, you
but
did
thank you
good.
so much for doing
Uh,
this mock with me.
no
Like
problem.
I've just been like practicing and stuff. So
No, this is good. This is good. Have you been watching the channel? You just tuned in out of random and just saw it.
no, I saw like some of the videos on the channel, and I thought like you were also very helpful to like other like students as well. So
Oh yeah, 100%. All right. So this is the next question. We're gonna be given a root of a binary tree. The tree is gonna have unique values, and then we're gonna be given an integer start. At minute zero, an infection starts from the node with value start, and each minute, a node becomes infected if it's adjacent to a node that's currently infected. Return the number of minutes it needs for the entire tree to be infected. So just think about it. We're just giving given a binary tree. One of the nodes is gonna start off as infected. It's gonna infect its neighbors. For each second, it will affect the adjacent neighbors. And then
okay,
you just need to tell me how long that's gonna take. I can give
okay,
a clear example if you'd like
yeah, yeah,
in the drawing.
yeah, okay.
Okay, or
Let
you
me
get it
just
or no?
uh, I think I kind of understand. I just
Okay,
want
go
to
ahead.
draw out like
Yeah, go ahead.
an example real quick.
You lead the way in the drawing, and then I'll answer your questions there.
Okay, okay, 1 second. Okay, so from what I'm understanding is that so you have a binary tree, right? Not a binary search tree, but it's consisting of some nodes like so. And we have some specified start um, S, like let's say ST,
Yep,
and all these nodes have values. Let's say this is 1, this is 2, this is 3, this is 5, and this is 7.
sure.
And so our start can be specified as let's say 5.
Yeah,
Then we have to start an infection.
yeah,
So every single time an infection happens, we are essentially like connecting to all adjacent nodes.
yeah,
So at minute 1, we at t equals 1, we infect 3,
yeah,
and then but then 3 at t equals 2, we infect 1 and 7.
yeah,
And then at t equals 3, we are going to finally infect our node of 2, right?
yeah.
Okay.
Yo,
Okay.
Chad, he's
So
doing good.
and essentially like
So
we
what's the
can start
result
at
here?
any possible
Did you say
point.
the result is 3? Or
Is three,
yeah,
yeah,
exactly.
because we have like visited all. Okay,
Yeah.
okay, okay. Um, and are we given the like number of nodes that we have in the tree initially, or like what are like the specific inputs that we have?
Well, we're just gonna be given the starting node.
Okay, okay, okay. So then I'd say the first thing we do need to check is we do need to see um like if a node is visited or not visited.
Well, actually,
And
we're
so
given the root of the binary tree, right? So this is a type node,
okay,
and then we're given an integer
of start. Okay.
of start. So we can assume start is in there. That's one thing to
Okay.
clarify. It's one of the nodes. And like I mentioned earlier, the tree has unique values. So you could identify the tree by its value or the node by its value. So, yeah.
Oh, so is this a binary search tree or it's still binary tree?
Just a regular binary tree.
Okay, 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 okay. Then in that case, I think the first thing that I was thinking about is first off, we do um need to find our start value. So in order to find this, uh we need to go through our tree a first time to locate like this position.
Sure.
So uh and this is at like some certain index.
Yeah.
And then after we're finding this start value, we're going to treat this start value as our new um uh treat this as like kind of our route where um we're going to DFS from. So originally, I'm thinking we in order to find the start value, we're going to do like a BFS to find start. And then after that, we're going to do DFS through the rest of the nodes. We're going to have a visited set. And every time we DFS, we're going to increment our time by one.
Every time
So
we DFS, we're going to increment time. Okay.
because that's like a
Let me just
new
follow up here real
node.
quick. Why do we want to use a BFS to find the first value? Is that like why'd you pick
Right.
that?
So just as as soon as we like find this, we're going to like break our BFS because we know where we're going to start the infection from.
Mm-hmm.
So in order to just find the initial location, but
Okay.
then
But why did you
I'd
choose the
say
specific algorithm? I just want to understand your knowledge with like the different variations of tree traversals. Like why did you
right.
choose BFS? Why did you make that decision specifically?
Actually, I want to change my approach from what you said. I think it would be more accurate to use, I think, DFS to originally find start and then possibly like BFS to do the rest because it is by adjacency. So the reason I changed my approach is because DFS is specifically for checking for specific paths, right? So like going down the levels of the tree and trying to find a very specific like max depth to find this could help find a node, right? A lot
Sure.
faster, I feel like. But BFS is more of uh taking all possible like other if I can change the I'm just trying to change the color of the okay, taking like other nodes. So and like checking your surrounding levels and like kind of expanding out. So I think BFS would be more appropriate in order to start the infection. Well, I think DFS is more accurate to find a specific value.
Okay.
Does that kind of make sense? Sorry.
So you're
I,
gonna
I, I kind of
yeah. Okay.
switched the approach.
So for finding the start, does it really matter what traversal we do?
I don't I don't. Yeah, I think we could use DFS or BFS
Okay. And then for
because
what about
it
for spreading the infection? Does it matter if we use DFS or BFS?
I still think it would be better to use BFS, but again, I think like you can use both. So
Yep. Okay.
like I'd say like but I'd say like in terms of like knowing and keeping track of like all of the possible nodes when you're spreading the infection, right? I'd say it's a lot like easier to do BFS on that since we're like using a queue um and we can keep track of all of that a lot easier. So that's just why I was specifically wanting to use BFS for the infection. But you can still do it with DFS and it would just be I think a little bit harder to implement. So
Okay. So what's your final algo?
Um, right. So I'd say DFS to originally find our start node, and then when we do find that, we can break, and then we start our infection using BFS. And every time we add uh, to our um, like visited set, or we like check all of our like neighbors of our binary tree, and then we add all of them. We have to increment time by one.
Okay.
So
All right. Go
yeah,
ahead. Go ahead
and
and implement.
I did have a question,
Sure.
another question. So since it is a binary tree, are we only given like L and R for like are we given like a parent to like go back into the like up the tree or
Well, we're only gonna be given the left and right child. Every node has a value and
okay,
left and right.
okay. Um okay, wait, I think then so if we're starting at the bottom of the tree then, if our start would be uh 5 for example, then if we're only given left and right, we can only check the values below that, right? But we would want when we're starting the infection, are we still allowed to go up from 5?
Where are you in the drawing?
Yeah, yeah,
Yeah,
yeah.
you can
Sorry,
start at
it's a
any
little bit
moment.
messy.
You can start at any node. So you need to so if you start at 3, then it's going to affect 1, 5 and 7 on the first iteration on the first on T1. Then T2 will
Okay.
finally. So, yep.
And this is a binary tree and not a graph or
Yeah, we're just given a binary tree.
okay. I'm kind of confused because then I'm not sure how I would like again like redirect it. I understand how to access the lower nodes and for like left and right for using left and right, but in order to like interact with like a parent node, then we would need to keep like an adjacency list of like all possible connections. And I think it would be uh better to treat this as a graph then instead
Hmm.
of a binary tree, if that makes sense.
Yeah. Well, the input is a binary tree. I mean,
Okay, okay.
technically you could change it to whatever you want though.
Okay, then in that case, I would need to like in order to spread the infection and I would need to go through the entire tree then, I think, initially. And initialize an adjacency list.
Okay. What will the adjacency list contain?
Um, it'll contain uh, child to parent, as well as parent, like just every single connection there. So parent to child as well, in order to like make sure that we can access like other nodes, if that makes sense.
Yeah. So the adjacency list will just have its parent and all its children, and then also for each node
And then
we want to store its parent also, so we have access to possibly up to three values there.
yeah,
Yeah.
exactly.
Okay.
Yeah,
Go ahead and start
yeah.
implementing. I think the approach seems fine to me.
Okay. So initially we're given a root, you said, and then our start value. Okay. And then I'm going to want to create an adjacency list. Um, let's call it, let's keep it blank for now. And then um, we're going to define our DFS from root. And if we don't have anything, we just return. Otherwise, we're going to want to store everything. So adjacency of root, uh, like say if root dot val is in adjacency, we're going to append uh, to our root dot val. And in this case, we're going to have to check if there is a root dot left and root dot right. So I think, okay, so if root dot left, uh, and then we're going to append this root dot left value, and we're going to also append this. And if root dot right, we're going to DFS, um, and we're going to do the same thing for root dot right. Oops. Um, the only thing is that we initially need to like check if we can like append this, since there are like there can be multiple values. So, and this is like a hash map for our adjacency list. So if root.val is in this, then we're going to do that. Otherwise, we're just going to like initialize an empty list with root.val or dot left.val. So sorry if it's adding a little bit of complexity. It's just because uh, we're originally given it as a binary tree and not as a graph.
That makes sense.
So
I understand that part. Just the code is getting a little messy. A lot
okay.
of statements here, if statements.
Yeah, yeah. I'm just trying to make sure that anything I'm adding to my adjacency list isn't like it still exists and um it is initialized just correctly and there's like no errors when initializing. Uh, unless you had like any suggestion for like if I should for any edits to this or
Let's just see where you end up, and then I can give
okay,
suggestions at the end of the interview.
okay. And I think the same thing can apply for uh root dot right. So I'm just going to copy this um and I'm going to say root dot right.
Also, for time check, we have about 10 minutes left.
Okay, okay, thank you. And then we have our start. So we're going to uh after initializing it, um I think we can still use this same function to run the infection. I'm just trying to think of how. Um, okay, I think
And
okay.
yeah.
So let's just call DFS of root,
Oh,
and
somebody! Oh, he
then
needs
after that,
some milk.
we're going to do we're going to define another helper, and this is like going to initialize our adjacency list, and then we're going to call this helper with the adjacency list of root or of our start. Sorry, this is going to help. Like, let's call it infection. Uh, infection. Define infection and say this is by root. Okay, and then let's also define a visited set.
Okay.
And so we have uh, if root is in visited, uh, then we're going to return. Um, otherwise, we're going to continue, and we're going to say for a in adjacency of the current element. So that's root. Actually, I think we just call this with start. Sorry. So
Sure.
start. So for a in adjacency root, we're going to continue running our infection of on A, and
All right.
then we're going to visited dot add. Um, we're going to add root to that. Yeah, to check, and then A in adjacency. What else? And then we do need to define our time. So t equals 0. Every time we finish a level, so after we iterate through every single possible route we do want to add to our time. So I think t plus equals to 1 would be here. Um, and
T plus equals to
visited dot
1.
add route.
Okay.
And okay, so and this is a non-local t,
Mm.
and visited is also non-local. Um, and I think then we're going to return t. Um, I do need to check if okay, so visited we add root, then we increment through, we loop through all possible infections, and then we add one to time. Okay. Okay, actually, I think this would only, if we keep recursing, this would only increment every single time by the time we finish. So I'm just trying to think of how to modify this in order to increment time properly. Um,
So we're pointing a BFS or a DFS. Like, what's the difference between?
uh, yeah, I think this is kind of like similar to again like a DFS. Since we have a visited, and then we're continuing to, but we're treating it as a graph with our like adjacency list, and we're continuing to look at other nodes. But um, I think
I mean, your
I need to
initial
like
approach,
modify.
you said you want to use BFS though,
Yeah, I can still change this actually. Um,
but it doesn't matter. But it's more just like you had an initial approach and then changed it up
I
last
I
second.
did okay. Yeah. Um, I'm just trying to think of like how to modify our T, in order for it to increment for like every single adjacent node.
Mhm.
Uh, would you happen to have like any suggestions of
Yeah,
um what to do to like properly modify the T?
yeah. Like the reason why I brought up that you mentioned BFS is or the BFS is
Because it would
because
be
it might be it the I think it's probably easier for the question.
okay,
There's
okay,
a
I
little bit
see.
of a
Okay,
hint, but
okay.
yeah. Because what do we want to do here? We want to well, I guess what where are you stuck right now? You're trying to figure out how to update T.
Yeah, exactly. Yeah. So
So what's the
I
problem with
think
T right
then
now? Is it gonna just increment up way too much?
it's going to increment too little.
Too little.
And because we're going to keep on adding to visited, then we're going to iterate through this, then we're going to recurse. And so I don't know like when specifically to increment to T because like either if we increment before, like here, um, then we're just going to be counting the nodes because every time we increment, we add and then we go through. Oh, actually, I think sorry, this would be the right place. Yeah, to add to T because we visit and like add something to our root, then we increment, and then we go through our adjacency list and recurse. Yeah, okay, okay. I think this would be the like right place to add to T. Sorry. Um, yeah. Sorry, my approach got a little bit muddled there, but I think
Mm-hmm.
this should like properly update to T.
So you now you just move the T before we go,
Are
right?
yeah, because right, because this loop is just going through and uh like adding and going through to all of the new nodes. If
Yeah,
I
so
can
if we
like draw
start
this,
so if we start
so
here,
how this would look like.
here go down a bit. So we start here. That's
Oh yeah,
one.
yeah, I see it.
Okay. So
Okay.
I'm looking at your code. We're gonna add this to visit. We mark it. Now we're gonna increment T equals 1. Then we're
Yeah.
gonna loop through each A, right? So
Yeah.
for
And so
each,
all of
we're
the
gonna call
possible
infection.
adjacencies.
So this guy's gonna increment to 2 because he's gonna hit 108, right? But then this guy's also gonna increment to 3
Oh,
because
I see. Okay. Because we're still okay. Because we go to a new node and then we still
exactly,
increment.
yeah,
Okay.
we're in infection and we're in a new node. So you're saying it's essentially every single node is gonna increment by T. So this is just gonna return 5. Make sense?
Okay. Yeah. So so okay, what would be the difference if we increment after? Then in that case, we would only increment too little, so it would still be only like one because we like go through all of them, we would return, and then the loop would exit.
Hmm.
Okay. In that case, because every time we call our loop, we're I think then yeah, I probably need to modify it in order to um
Yeah. I think we're pretty much
I
at
just
time, so
okay.
we'll
Okay.
just probably end that here.
Okay.
How do you think you did?
I think the last question was like kind of bad. I honestly was like trying to think of like other approaches also while like explaining it to you. And I think that's what like I could have spent a lot more time like planning my approach, but again, like because of the time I like didn't want to spend too much time on the planning. So that's kind of why I like went into implementing and trying to get something um done. But I think like the last part, like when you like said like, oh, like it is going to like I think I should have used like a BFS instead. And like processed it with a queue maybe, uh, and then tried to like based off of that, like kind of have it like a level order and like increment every single time I was BFSing, if that makes sense.
Yeah, that makes sense. All right. So like, how did you feel about the interview? How are the nerves? How is the thought process? Like, how would you rate yourself if you had to give yourself a rating?
I think like honestly like probably s- like 6 out of 10. I don't know.
Out of four,
Like
so
because
high,
out
no
of four,
strong, no higher, no higher, lean higher, or strong higher.
I th- I
Would
think
you?
I'd say like lean higher to maybe even no higher because like I think my first problem I was like pretty like confident in like figuring stuff out, but like the second part I kind of like leaped into implementation, spent like less time on the planning, so probably
Yeah.
like lean higher to no higher. So
Okay. Let me give you my notes. Let's
okay.
see. So I think I would probably give you the same rating, which would be honestly you were on path to being a strong hire. Honest, like 30 minutes in, you're killing the interview essentially.
Okay.
But then, yeah, I think what folded you was the BFS part. But let's start with Q1. So I think the way that you think about the question and you like methodically work through getting the question and getting to a solution is great. That's your thought process is perfect. You do it the way that an interviewer would like, which is clarifying the question, coming up with some solutions and getting buy-in from me on which solution to go with, then going ahead and implementing it. You have no trouble with anything related to implementation. You're able to implement it well, right?
Okay.
I think for the first one though, you didn't really analyze the time complexity correctly right away, especially with like
Okay.
the array
Okay.
dot copy. So I think definitely be able to understand the time complexity there. Do because yeah, but some of these mistakes you caught for yourself. So you initially were just gonna do a shallow copy where you just did array equals copy, but then if you modified that later, it would also modify because it's pointing to the same reference. So that wouldn't have worked. There's a couple things
Okay.
that I had to ask you to optimize. So some of the stronger candidates would just they'll notice right away that they don't want like it would get it would turn into an O event squared algorithm with the copies with the resets. I wouldn't have to prompt them there. So that's one area where you could improve. But your for the internship position is not bad. Where I had to sort of prompt you for optimizations. So you would propose something and then I would call out where it's unoptimal. But as you move on to the higher levels, you should be able to look at your algorithm, propose something, and then catch yourself when it's not optimal to speed it up. But I would say don't worry about that now for because it's an internship role. But
Okay.
like actually, if you can find yourself and you notice there's inefficiencies, definitely call it out before interviewer does.
Okay. Okay.
So I think good problem solving skills. The only thing is I needed to drive the conversation, which I like I
Okay.
mentioned is good for is fine for intern, but as you increase in level, you need to drive it yourself. Your variable names
Okay.
could be improved. Like using M there was a bit confusing.
Okay.
So when it comes to some of these companies, they really actually care about your variable names. You can't just use like M, A, C, J. KV is
Okay.
fine, but M for an important dictionary like
Hash
that
map.
is
Right.
is
Okay.
not a good variable name. So yeah, I think Q1 I would actually give you a solid higher there for Q1, maybe even a strong higher because I've seen lots of candidates flop that. So
Okay.
second question,
It's just
or go
the
ahead.
second
You have any
question,
question?
I was just not sure on. Like the second question, I was not sure on my approach, and then I think that like is what caused like the issue.
Yeah,
I was like kind of like not so familiar with exactly like a clear path of like what I was going to do, and I think because of that, like I kind of like over indexed on like implementation.
yeah. I mean, we could start with some of the stuff you did well in Q2, which was clarifying the question well. You understand what else did you do? You understood that we couldn't look upwards in the tree if we're at a node, that we need to build an adjacency list to find the parent. So
Yeah,
that was good. Some people don't realize that, but you're able to
that's
realize
why I
that.
was like,
Or go ahead.
should we do a graph as well? Like, and should we like make it like a graph because like the infection can spread up. So yeah,
Yeah.
yeah.
So I think where you got caught up here is just not understanding when to use a BFS or a DFS. So
Okay,
you need to really understand the difference between BFS and DFS. If your goal is just to find a random node in the tree, it doesn't matter if you use a BFS or DFS.
right, right. Okay,
But the way that we need to spread the infection is level by level. So naturally,
okay,
using a BFS makes it a lot easier because every level we just increment it. And since we're traversing level by level, we increment it on every single level,
okay,
right? So you could think of because it's just a breadth first search, right?
right.
We start at one node. So this is if you come into the drawing, we start on one node. This is infection node. And then after,
Okay,
we're going to spread to our neighbors, right? Then we're going to spread to the next level. So every level away from the source is going to increment by one. So if we're performing a DFS, you could solve it if you pass down the level, but
okay.
it's not as natural for this question. So yeah, what was your reasoning there of why you decided to use a DFS or a BFS, or were you not thinking, or why didn't your mind go towards BFS? I'm just curious because you did mention it.
Mainly because I like just wasn't sure how like to process it like with a tree, right? Instead of like that's the like initial like confusion I had. So with a tree, like how would it look like when I was like processing these nodes, right? And then I realized like, oh, I was just
Caesar
going
with the
to
two
like use an
bucks.
adjacency list anyway. So then like wouldn't it be like maybe shorter to do just like a DFS for this? And that's why like I like turned and like changed my implementation here towards the end. And I was just trying to like rush through and
Yeah,
like trying to like get like a working sort of solution. But I feel like the main thing is like how I was incrementing t and my time variable. I wasn't sure where exactly to like add that
yeah,
when doing DFS or BFS. But yeah, BFS would be more appropriate, I guess, because like you are just checking like where all your adjacency lists is. So like you're adding all these to your adjacency list and then you're processing them one by one by one. So every single time you process a level, you can just increment to time. So
Exactly. Yeah. You could just perform a level order traversal. Have you done a level order
right.
traversal before?
Yes, yes, I have.
Exactly.
Yeah, yeah. Like a standard one. Yeah,
Yeah.
yeah, yeah.
So you could perform a
So
level order. This essentially turns into a ternary tree where at most it could have three nodes because
okay,
and
okay.
then you just do it's like level order traversal on a ternary tree. So the way that you'll have to
I
do the
see.
order traversal is different because you're gonna need to loop through one level at a time and then increment. So it's not the same as like how you would do it with just a regular BFS. You're it's gonna be a slight variation, but if you've done it before, you should be able to solve it. Um,
Okay.
yeah. With the here the code could be cleaned up a lot by using default dictionary or get element. So
Oh, okay, okay. Yeah,
you could
yeah.
use that
In
to
order
clean it
to
up.
initialize eventually. Yeah, yeah.
And then I think the last thing would be that you should you change your initial approach from what you initially proposed. So usually what you would want to do is or so in some of my companies we would mark based on if they implemented their initial approach because some people would
Okay,
come up with a solution and then as they're implementing they're making multiple changes to how they're going to implement it and it
okay.
ends up being a completely algorithm or different algorithm than it was before. So
Right.
like the best candidates are like, okay, I'm going to do this, and then they execute on it and they kind of figure things out up front of how they're going to execute and only figure out
Okay.
they only like change it slightly based on things that they uncover, which is fine. But you completely change from like using a BFS to a DFS, which
DFS, right,
it's like
right.
somebody tell me they're gonna do a sliding window, then all of a sudden they're doing a prefix solution, right? It's completely different. So
Okay.
I would just try
Right.
to stick to
Right.
what you initially proposed. That's just like a small thing.
Okay.
Um,
Okay.
I don't think you'll get docked, but that's just advice when it comes to interviewing.
Okay.
Yeah. So what's your interview looking like? It's just Airbnb. Like
Uh,
what school do you go to?
I go to UIUC.
UIUC. Where's that? University of Irvine?
It's in Illinois.
Okay. Oh,
Illinois.
okay.
Urbana-Champaign. It's
Oh, I
like
know.
in the
University of Chicago,
Midwest.
right? That's a good.
No, 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 no.
Oh,
It's like 3 hours lower from Chicago. So
okay. And then you only have this interview, or you have multiple?
I just have two rounds, two technical rounds for this.
Or I mean, which companies? Are you just doing Airbnb, or you have multiple?
Oh yeah, so I am in process for other companies. I'm just like waiting to hear back for scheduling interviews, like some other like Fortune 500 and startups and stuff. But
Yeah.
this was the main like big tech one that I had.
Okay. Okay. I'm gonna. Have you seen my list, Peralta 75 list?
Yes, yes. Yeah.
If you go on there, try. What I would say is practice the graph questions there. You'll see graph
Okay.
questions there that you won't really see in normal list. But if you could do all these graph questions, you should be good. Like
Okay.
try bus routes. That's a really good question. It's hard, but it's actually more of a medium question. Try walls and gates. Definitely try number of provinces.
So, oh, I've done cheapest flights within K stops,
Were you
and
able
I've
to solve
done,
it?
I think, yeah, I think, and then accounts merge, I was using union find instead of graphs.
Nice.
And then I think number of islands I've done, I haven't seen walls and gates before, and okay,
Okay,
I don't think I've seen some of, I've done
try
alien
maze
dictionary
2.
though. Yeah.
Try maze 2 as well. Maze
Okay.
2.
Okay.
So just try some of these graph questions cuz I think but and really try to understand when you're making a decision of DFS or BFS, try to be able to explain why you're making that decision. Is it
Okay.
arbitrary? Could you use any, or would using one better than the other, right? And if you're performing a in order, post order, pre order traversal, also be able to explain why as well.
Okay.
So try trees as well. So go like on my trees list, try out like sum to root, cousins in binary tree, and then try 98 valid binary search tree. Or no, sorry. Validate binary nodes 1361. So those are good ones that should prep you up. I think you need a little bit of practice when it comes to trees, but you're 90% of the way there. Probably like 2 days of effort or 1 day, you're good.
Okay, okay. Thank you. Yeah. I'll definitely like start prepping that. And then as for um like in general, like my thought process, would you say it's like kind of on the right track, like narrowing down like which solution to find or which like approach to use? Like what would you say like I can do to like better that in terms of like picking between like, oh, like BFS or DFS, or like picking between like, I don't know, using like a data structure or not? Like,
Yeah, honestly, the only real mistake that you made the whole interview was using a DFS over a BFS and then not knowing how to
okay,
update the time. So
okay,
you did a lot of things well, like figuring out that we have to build an adjacency list. That's something not every candidate gets. I've folded lots of people with this question. So
okay.
you're able to solve it, which is good. And I mean, you suggested BFS during planning. That's why I mentioned, I was like, why'd you switch? But
Right, right.
so I
It was
think,
just because I thought like there was not enough time, and then oh, I should do like I think DFS would be faster maybe. Since
yeah,
I said DFS or BFS was valid, but
because you're not as maybe you're not as confident with the BFS then. Like you didn't think that you're gonna be able to code it up real fast. Is that why? But honestly, you already had the solution. You had 20 minutes plus to start coding.
okay, okay,
So I mean, you had 20 minutes to implement it. So you were good. Like for time, you were way ahead of time. Honestly, with just a little bit of practice, you could have went from a lean hire to a strong hire. Everyone in the chat was saying you were killing it, and then all of a sudden,
okay.
that small decision would cost you. But it's all good. I'm not worried for you. I think you're gonna get the job. Oh, I accidentally left. Oh shoot. Let me join back in. Let me join back in. That was rude. Oh shoot. I closed the tab. So
Oh,
so
okay.
yeah. So how are you feeling? Are you How was that experience? Did you feel like you got better from that experience? Did you realize things about yourself that you didn't before? Like how's
Yeah,
that?
yeah. I think it's just like kind of like a common mistake that I usually make where like I usually like get like very nervous towards the end of the interview, like for time limit and try to like rush through like implementation. So I'd say like I still need to like I guess like improve upon that. But yeah, like I'd say like I'd also like learned to like I think I need to like know exactly when to like spend more time on planning and spend more time on like implementation
Yeah.
and making sure that like I can do that.
Yeah. Okay. All right. If you need another mock, Alpha Code does mocks as well. I'm not sure if you know Alpha
Okay,
Code.
okay,
He makes videos on it too. But
okay,
you should book a mock with him. He's done a lot more elite code questions than me too, and he gives really good advice.
okay.
But he's booked out for like 35 days, but I'll send him a message. When's your
Ah,
interview?
okay.
Wait, when's
It
your
it is it is in 4 days, so
Okay,
it
he'll
is
probably
very
be able
soon.
he'll squeeze you in as long as you show up.
Okay, okay.
I don't know if he's in here. I'll message him, but yeah. All right, cool. Thanks for hopping on. Good luck on your interviews and
Yeah,
just
yeah.
join the Discord or message me anytime you need advice on like if you have to do system design or any leak code questions you get stuck on. Just hop on the Discord.
Yep.
Everyone's responsive
Thank you
there.
so
All
much.
right. All right, see you, man.
See ya.
I've done so many C++ interviews. All right, chat, I got to rest 30 minutes. And then I'm gonna do the leak code contest. Maybe we can debrief after while watching the UFC fights. Let's see. Let's see. What's the got the leak code contest tonight. How's that? How am I mean? What question? That guy did well though. I'm here to prep people. I'm here to give them a question so hard that any Fang interview they'll be able to pass. They're not gonna ask questions that much harder than that. Maybe probably might be a little bit harder, but if yeah, it was just a leak code medium, bro, honestly. But I'm not here to go easy. I'm not here to make people feel good about themselves. I want them to actually get real life interview questions. 1600 rated? All right, chat. Let's see. 16 nah, yeah, it's not 1600. I'm going to go for a walk and then we have the contest starting in 31 minutes. So I have to rest up and handle business. I'll catch y'all on the next stream.